Let's look at problem 7 on the 2023 AP Chemistry free response. This question is a solubility equilibrium question. That's KSP, stands for solubility equilibrium. And basically, this equilibrium constant tells us about how much a solid salt compound is likely to dissolve in favor of the products, which are ions, or how insoluble the salt is and how much it could actually favor potentially the reactant, which is the solid salt. So in solubility equilibrium, the solid is always on the left as your reactant, and then these aqueous ions are always on the product side. And so if we look at our KSP constant, it will equal the concentration of strontium times hydroxide squared. So those are the concentration of your products raised to their mole ratio divided by, in this case, is divided by 1, okay, because your reactant, usually the reactants go here, but this is a solid as a reactant, so we don't have a concentration for that. Okay, now in question A, a student draws a particulate diagram to represent the ions in the aqueous solution of strontium hydroxide. The water molecules are not shown, and there is an error in the drawing. So what really just comes to my mind is that the hydroxides in this student's picture, there's 4 of them. And there is also 4 strontium ions, these shaded in circles. And if I look at the balanced equation, I notice that strontium ions to hydroxide ions, there should be 2 times of the hydroxide ions compared to the strontium because of this 2-to-1 mole ratio. So the main error that I see here is that the student's drawing does not reflect the mole ratio. All right, and what that means is we should have 2 times the number of hydroxide ions than we do strontium. So really, we should have drawn 4 hydroxides and 2 strontium ions. Okay, so hydroxide ions should be double that of strontium ions. In the next question, the student prepares a saturated solution by adding excess strontium hydroxide into distilled water and stirring until no more solid dissolves. The student then determines that the strontium's concentration was 0.043 moles per liter in the solution. Calculate the concentration of OH negative. Okay, so actually this is related to what I just said up here. We know that the OH negative concentration must be double that of the strontium because of the 2-to-1 mole ratio. So here's how we show our work. We're going to say that we're going to take our given value. It's a mole ratio problem. So we know that there's 0.043 moles of strontium per liter. And when I set up my mole ratios, I like to multiply it by a fraction. And what I like to do is I like to put the units of the units that I don't want on the bottom of my fraction, so on the denominator. So in this case, for example, I don't want moles of strontium. So that will go on the bottom. I do want moles of hydroxide, so that will go on the top of my ratio. And in terms of the numbers, again, if I go back to my equation at the top here, we know that for every 2 moles of hydroxide produced, there is 1 mole of strontium ion also produced. So in this ratio, moles of strontium cancels out with moles of strontium, and that will give me my answer. If we look at the units, the answer will be in moles per liter of hydroxide. Okay, so when we do this calculation, I get 0.086. We'll round it to the same significant digits that I'm given in the question. There's 2 sig digs here. So this becomes moles of hydroxide per liter. And you can also remember this unit can also be expressed as 0.086 capital M. That also means moles per liter. All right, now let's continue in question 2 in part B. Calculate the value of KSP for strontium hydroxide. So that's not too bad of a question because if we go back up to the top, let's draw our attention up to the question here. Notice that they've given me the KSP expression, so the formula, And so I'm just going to plug, I actually know my concentrations here because that's also given to me in these previous questions we solved. So let's write down our Ksp formula. Ksp equals concentration of strontium ions times concentration of hydroxide ions squared. Okay, so remember you have to raise it to the mole ratio. So in my strontium ions, I actually have, in this question, 0.043 moles per liter. And then in my hydroxide, which we calculated, it's double that, so 0.086 moles per liter squared. So my strontium hydroxide salt has a Ksp value of, we'll round it to two significant digits, so 3.2 times 10 to the power of -4. Remember, your K constants are unitless, so there is no unit in my Ksp answer. And what this actually means, this value, is that my equilibrium will favor, you don't have to, this is not part of your answer key, but because K is less than 1, the equilibrium favors the salt. So what that means is the salt is not very soluble. I favor the salt, I favor the reactant. And yeah, that's how we do a problem like this for question B. The final question here in 7 is asking about a student prepares another saturated solution of strontium hydroxide. But this time instead of dissolving this solid in water, you're dissolving it in a solution of 0.1 moles per liter strontium nitrate. So it's asking, will the value of OH in the second solution be greater than, less than, or equal to the value of the OH in the first solution? So what we have to think about here is we can maybe visualize it, okay? So what I'm going to do is I've got a solution here of strontium ions and nitrate ions. And I'm going to try to dissolve strontium hydroxide into this solution. And actually, because this ion already exists, strontium, it's not going to be very soluble because this is actually called the common ion effect. We have a common ion here, which is strontium. And what that's going to do, this common ion effect, is going to increase the concentration of strontium ions. So if I go back to my original equation here, this SrOH2 will dissolve into Sr2 plus OH1 minus. If I look at this equation and I'm trying to dissolve this into a solution that already has strontium, what that means is that this concentration is very high. So I put an up arrow to show that the strontium ions, there's a lot of them. And actually, sorry, this is an equilibrium. Because of this common ion, it makes the concentration of strontium very high, which is not going to favor this hydroxide. So it's not going to favor the dissolving of the salt. In fact, what's probably going to happen is we're going to shift backwards. This is called the Le Chatelier's stressor, where we are adding some sort of stressor, which is this extra strontium ion, and that's going to cause these products to collide. You have extra collisions on this side, which is going to shift my equilibrium backwards to the solid. So because of this common ion effect, I'm going to have less OH produced in the second, so in this scenario, in the second solution, because the common ion, strontium, causes the equilibrium to shift left back towards the salt. All right, hopefully that makes sense, and you can watch the next video for the next question.